is 3 divided by 3? Everyone agree with that? 3 divided by 3 is 1? Okay, because of that, you're still going to have a 1 on top. Every once in a while I get a student in this situation who leaves a 0 up here. It's not true. You're not subtracting 3 from 3, you're dividing 3 by 3, so that leaves a 1 up there. So this would be the simplest form. This trick over here that I showed you, of splitting it up into 2 fractions with addition, will not work when there is addition in the denominator. It only works when it's in the numerator up on top. Addition in the bottom, you can't do it. That's a longer question than I think I was ready to answer today, so let me think of a good answer for that. Yes, sir?
Is the 3, when you know it says 3 over 3a plus 9?
Yeah.
And it says equal to 3, is the 3 in the parentheses, is that because you divided 9 by 3?
This is, yes. Well, basically, again, I don't like the word divide in this situation. I factored. I know, slight difference. It looks the same to you guys at this point. This is because 3 was a common factor of 3 of 9, Jordan, so I pulled the 3 out of both terms, yeah. Just think about it, if I redistributed, it'd be 3a plus 9, right? That's my one rule of factoring, sir. If you can redistribute and get the same answer, then you have factored correctly. Okay? Doesn't just work this way for numbers. All right, now I'm going to do another example.
Wait, I have a quick question.
Yeah.
Can you explain this quickly?
Yeah.
What would happen if it was on the bottom for...
Okay, let me try an example.
I mean, don't show it if it's going to confuse us.
I don't, maybe. If you have 3/7 of something and 4/7 of something, what have you got?
So it's a 1.
You got 1. You got one whole thing. So 3/7 plus 4/7 is the same as 3 plus 4 over 7. You can picture that. If I took a cake and cut it into 7 pieces, gave 3 of them to somebody and 4 of them to somebody else, one of them would have 3/7 of the cake, the other would have 4/7. They would have come from the entire cake. So this seems to be true, talking about our cake, whether I write it this way or this way.
Oh, but on the bottom, because that's what you have as a whole. So
Yes.
that's why, okay, I get it.
Right, but exactly. But if I do that on the bottom, well, with numbers it'll actually work. But with numbers on the bottom, if I have 7 over 3 plus 4, this means 7/7, right? This will not equal 7/3 plus 7/4. For one thing, is 7/3 bigger than 1?
No. Well,
Yeah, it's 2 1/3. Is 7/4 bigger than 1?
Yeah.
So this is going to be some number bigger than 2.
Except it would still work if you split those 2 up, so it would be 3 over 3a plus...
If you could split them up and put them back together, you would get the right. It would be a case of 2 wrongs making a right. But you can't do either. But yeah, you're right. You know what? I think I see where you're going with this, Jenny. If you did split these up, work out the 3's, and then recombine them that way, you would actually get the right answer. But that would be something that happens only in math, where 2 wrongs will actually make a right. That's kind of coincidental. You don't want to do that as a general rule. You want to stick with this rule, where this is obviously 7 over 7, which is 1. This is 2 1/3 plus 1 3/4.
Then you'd have, yeah, I get it.
Which is 3 and something. Okay, so these two are obviously not equal, so this rule can't work in general. But you're right, if I put this back together, I can take it apart and put it together and get the right answer for completely the wrong reasons. This did not confuse you further? Good, thank God. Fractions are hard. I once tried to ruin the career of someone I didn't like using fractions.
You told us.
Should I stop? I should have stopped this film.
No, that's fine. That was fine. This is good to be on here. This is actually
No, you said you should ruin somebody's career by that.
That's okay. I failed to ruin their career, and he was a jerk and deserved it.
What was the example?
Alright, I'll tell that story at the end, but
Okay.
now I'm going to get to that example. Okay, now the
Wait, but
example
what
is
is
gonna
the
be-
trick that you're using on that one right there? That's what I was trying to figure out.
Okay, well hang on a sec. Let me do another example here. It won't always be numbers top and bottom where this will work. Let me show you another example. If I do 3x plus 21 over x plus 7.
I do it.
Now Jenny, here's where
You could do it that way.
well, here's the funny part. Here's where actually this trick here of splitting it into 2 fractions actually won't help us. Because we could do 3x over x plus 7 plus 21 over x plus 7, but this doesn't really help us anywhere. Now it looks like we can't do anything. So this trick really starts failing quickly once you get to real algebra expressions on the top and bottom. But I would rather light a candle than curse your darkness. So here's what I'm going to show you what to do. Okay?
Because we're not going to have any problems.
Oh yeah, we are. I just said this. I didn't say we wouldn't have any. I said that trick totally stops working here. But there's another one that works. If we just think in terms of factoring, Nick, what is the largest number that goes into 3 and 21? 3. Jordan,
Yeah.
after I pull the 3 out of 3x plus 21,
3x plus 21.
x plus what?
21.
No, 3 times 21 would be 63.
Yeah, 63. 7.
How are we doing today, Jordan?
But why are you putting? Whoa. I thought you just said it was 63.
No, I was saying, Jordan told me to put a 21 here, and I was saying to Jordan that if I put a 21 here and did my check of redistributing to make sure I did this correctly, 3 times 21 would have been 63 up here. Since we did not start with 63, 21 must not be the answer here, and 7 must be. More than you need to know, Brandon. Okay, don't worry, we'll get that. Ask me later for that one. Now, the x plus 7 on the bottom stays the same. So I factor a 3 out of each of these, and I get 3 times x plus 7 over x plus 7. Jenny,
It's going to equal 1.
close. It's not going to equal 1. I can now cross out the x plus 7 and the x plus 7 because they are the same thing.
It's going to equal
So this will equal 3 over 1,
3.
or just 3. Okay, so it turns out you can cross out entire algebraic expressions. I thought you'd like that, Jordan.
Can we do another one?
Yes. Now, Nick, there is a trick to this, however, and I just want to mention this to everybody real quick. In later classes, you will learn about a problem with this. And the problem is that if x equals -7, you have 0 over 0. And you're not really allowed to have 0 over 0. So if you see, I'm not going to be too picky about this book, but technically this is only true as long as x does not equal -7. I'm not going to be too picky about that now, but just so you know, you're going to hear that later. Because you guys have heard how you're never allowed to divide by 0?
Yeah, there's always equal 0.
Now, divided by 0, it equals 0 on the top. Dividing by 0 doesn't equal anything. Dividing by 0 is a little crazy. I'll go into that in a little more detail later. So, whatever would make 0 on the bottom, you're supposed to say x can't be equal to that. This only equals 3 as long as x does not equal -7. For any other thing you imagine x to be, +7, 52, pi, I don't care.
How
Whatever
did you
else.
get -7?
What plus 7 equals 0? Yes, it's whatever number would get you a 0 on the bottom.
You want to get to 1.
No, we don't want any, well the 1 is already here. The 1 is always implied to be there. Okay? So we just don't want this bottom to be 0. That's the only point of saying this. So you got to say whatever would not make the bottom 0. You with me on that, Nick? No bottom 0. Okay, thank you. Now, I'm going to go over here for my next example, and I'm going to show you just how much fun this can be, and just why you guys are no longer allowed to forget things from unit to unit and test to test.
Oh, what pages are in the book?
666. This is the chapter of the devil.